MIT App Inventor Research Group has developed an early prototype of a conversational agent to enable nearly anyone to program using voice.
One of our questions was, is speech recognition good enough for this project? Or is natural language understanding at its current state good enough to do something like this? For instance, you could have an unconstrained natural language system, which means you can say basically anything to the system and it would hopefully understand it. There are some problems with that because there's a lot of ambiguity with natural language. And so what we decided to start with was a constrained natural language system. And that means that you can only say specific phrases like create a variable or create a loop, and the system will understand those phrases. But if you say something different, like I want to make something that repeats 5 times, it probably won't understand that.
The first study, the group was looking to see which systems users prefer, the talk or text.
We brought in a bunch of different people. So there were novices, people who had never programmed before, and then advanced users who would basically do this for their job.
The goal of this was to see if novice experienced programmers can learn computational thinking skills through these conversational techniques. The subject would be in a classroom-like atmosphere and begin talking to the systems and running through a practice stage that gives them time to get the voice and text-based system. Then they move to a novice stage.
In the novice stage, there's a particular goal. So in this case, it was generally about whether you could make a program that would take in user input. So take in something that I said as an end user, someone who isn't creating the program. And if whatever I said was the word dog or the word cat, then the system would output or create a noise that was like a woof or a meow, depending on the input.
All of the novice and advanced users were able to complete the novice stage, in which the advanced programmers moved on to the advanced stage.
Very similar to the novice task, but instead of just doing this once, this user input and then output, they would have it repeat in a loop.
The group had surveys throughout the experiment, allowing for users to provide feedback.
We had them answer questions about it, like what did they prefer, right? What was useful about the system? What could really be improved, right? And what kind of questions do you have about the systems? And so we ended up analyzing that data. We found that actually advanced users, when they were using the text-based system, they found it kind of cumbersome because they were writing out all of this natural language, right, which is generally a lot longer than what you would do when you're writing Python code or something like that. And so they actually would have preferred writing Python code. But what we found with novice users was that they were really excited about the system, especially the voice-based one, in a way because it was really efficient. And so we found that novice users liked voice because it was efficient. Advanced users might have preferred using a programming language itself. And so what we actually want to create is a system for K-12 education to lower the barrier to entry to programming.
The experiment was a success, and the group ended up coming up with design recommendations for future conversational systems that will hopefully work into creating a system for K-12 education